Imagine we have a ball or a particle or a stone or whatever that is. So here it is. And suppose we project this fellow with some velocity u at some angle theta. Then we know this guy is going to go into some sort of a parabolic trajectory and is going to hit the ground back with the same speed u with the same angle theta. Now there are certain things, there's something special about this, and the speciality is that the stone comes back to the same point, same level. You can see here's point A and here is point B. It has returned back to the ground. It's supposed to return back to the ground. And whenever you see that particles are returning back to the ground, there are some ready-made formulae available which we are going to exploit duly. So this is the range formula. We're going to have one formula for range, one for the maximum height, and one more for the time t, time of fall. The three formulae which you must remember. It's not a necessity to remember that, but you can do problems faster if you remember it. And those formulae will be t equal to 2u sine theta divided by g, h equals u square sine square theta divided by 2g, and you have the range which is u square sine 2 theta divided by g. And we're going to try and understand what will happen when you change different things. Now notice that when you increase your speed, obviously all the things start increasing. That makes pretty much sense. For example, you throw something with a low speed, it's going to fall like this, and high speed is going to fall this way. But notice that if you double the speed, the time of fall doubles, but the height and the range, they become 4 times more. Something to remember when you're solving problems. Alright, so here's a u square dependence, but here's just a u dependence. Alright, another thing to note is sometimes they ask you to throw balls and particles in different planets. So it depends on the gravity, so that also makes sense. If you go on the moon, for example, where gravity is just 1/6, gravity is just 1/6, then the range and the height and the time, all of them are going to be 6 times more. You'll get more, everything to be more, 6 times more. But the most important thing is the angle, to understand the dependence on angle. Okay, let's see. If you want to have maximum time, so you want maximum time and you want maximum height, let's say. Maximum. You want to make sure that the ball spends a lot of time in air, in fact maximum. And eventually it's going to be, and because of that it's going to have, you want it to reach the maximum height. What do we need? Well, we want these guys to become 1, the maximum value. And that only is possible when theta is at 90 degrees. That's the thing. Theta at 90 degrees is when you get maximum height and maximum time. But when do you get range to be maximum? This is also quite important and it's quite famous, and I'm pretty sure you know about it. Well, we need 2 theta to be 90. So we want theta to be 45 degrees. 45 degrees is where you get always the maximum range. And there's something else about the range. You see, because there is sine 2 theta inside, for 2 values of the angle, you will get the same range. Let me give you an example. If you take theta as 30 degrees and you take theta as say 60 degrees, sine of 2 times 30 is sine 60, which is equal to root 3 by 2. And sine of 2 times 60 is sine 120, which is also equal to root 3 by 2, because sine is positive in the second quadrant, which means you get the same range. So the range is exactly the same. So range at theta equal to 30 degrees and the range at theta equal to 60 degrees are equal to each other. The general rule is if you take any angle theta, then you will find 90 minus theta also gives you the same range. So you get same range for these guys. So other examples would be something like if you throw something at 20 degrees, then you will get the same range for 70 degrees. But notice that for 70 degrees, you will get more height. So if you were to see what would the projectile motion look like for 2 different angles, say you chucked one at 70 degrees, this is 70 degrees, I'm not going to draw that over there, okay? And you threw another fellow at 20 degrees, imagine that's 20, I know it doesn't look like that, but imagine 20 degrees. Then you would see that they'll both have the same range, but they will have different height. So this is how you can imagine, because 70 plus 20 is 90. So height will depend on the angle definitely. More the angle, more is the height and more is the time. But that's not the case over here. If your angle is closer to 45 degrees, that's when you get more range. See here, 30 is 15 less than 45, 60 is 15 more than 45, so you end up getting the same range. Same over here, 20 is 25 less than 45 and 70 is 25 more than 45. Again, you get the same range. So in order to get the maximum range, you either have to get 45 degrees, but if you can't get, then closer your answer is to 45 degrees from either sides, more or less, closer to 45 degrees, bigger will be the range. I hope this part is clear to you.